Okay, we are going to finish up the last part of the lesson today, and we're going to be talking about inscribed triangles in a circle and inscribed quadrilaterals in a circle. And there's a couple properties that we need to refresh our memory on by doing so. So the first thing, when we have an inscribed triangle, think of that as inside. So our triangle is inside the circle. One of the properties that you're going to use to help you solve these types of problems is that the degrees of a triangle add to 180 degrees. Okay, so 180 degrees in a triangle. So that's a property there that we need to remember. And then when you have a quadrilateral inscribed or inside a circle, so remember, quadrilateral, 4 sides, not necessarily a parallelogram or a rectangle or a rhombus, just think a quad, 4-sided figure, inside the circle, the degrees of a quad add to 360 degrees, and opposite angles are supplementary. So opposite angles are supplementary in this case because it's inscribed inside of a circle. Now supplementary, you can remember, is 180 degrees. Complementary 90, supplementary 180 degrees. So now let's look at some examples using those properties. So for example 15a, we have a quad inscribed inside of a circle, and we're going to find the missing variables. So angle A we need arc B, and we need arc C. Okay, so we're going to start out by finding angle A. Okay, so think about what you just learned. You just learned that with a quadrilateral, opposite angles are supplementary. So opposite or supplementary. So I'm going to do this. Supplementary meaning 180 degrees. So I'm going to come down here and show my work for you. So 180 minus, that 87 degrees, that's an 8, is 93 degrees. Okay. So we just figured out that this is 93 degrees. So if I add both of those, I'm back to 180. B is an arc. So in order to find that arc, I need to either know a central angle, which we do not, or an inscribed angle. So I'm going to try to highlight this to make it easier for you to see. So I see this 78 degrees, and there's different ways to solve this problem. But if I follow my angle of 78 degrees, my intercepting arc is from here all the way around to this point. Okay? So I can figure out this whole measure by doubling my angle, by multiplying by 2. So I'm going to draw the green to match the highlight all the way around to there. And we're going to say 78 times 2, so 2 times 78, which is going to give me 156 degrees for all of that green area. But if you look, we only need this purple. Well, if I know the whole thing is 156, and this much of that is 35, I can just subtract that 35 from 156. So 156 minus 35 to give us 121 degrees. Okay, so now I need arc C. Okay, C is an arc. So for this one, I'm going to basically do the same thing. I'm going to look to see, okay, what angle could give me an intersecting arc. So if I look at angle A, that's 93 degrees. So if I follow this, I'm going to go with a different color here, all the way to here. Again, it's going to give me too much, but that's okay. So I can double that, 93 degrees. So I can do 2 times 93 to get 186. So if all of it's 186, I can subtract off this 35. So 186 minus 35 for 151 degrees. So lots of steps. So just remember your rules. For example B, we've got to find this arc. We've got 2 angles to find. So I'm going to start off with arc A because I see that it's directly across from this inscribed angle. So if it's inscribed, remember we double it to get our arc. So we're going to say 2 times 32 to give us 64. And then I look at angle C, and I see that I know the arc across from it. So I'm going to work backwards just a little bit. If I know the arc and I've got an inscribed angle, I want to do half of the arc. So half of 122 to give us 61. Label your picture as you go. So now if you look at your triangle, 180 degrees in our triangle, I now know 2 angles. So to find B, I'm going to say 180 minus the 32 minus the 61 to give me 87 degrees for angle B. On our last example with C, you've got 2 triangles inscribed. Okay, for C, I've got angle A, angle B, and angle C. So if I look at angle A, it's inscribed, vertex on the circle, intercepting arc, 76 degrees. So A is going to be equal to 1/2 of 76, or 76 divided by 2, which would give us 38 degrees. We've already talked about this. If you look at B, B has the same intercepting arc. You learn that these 2 angles are congruent if they have the same intercepting arc. So you can either do the work again if you couldn't remember that, or if you did, you would just go straight to the 38 degrees. Okay? So then for C, you may say to yourself, well, this is a central angle. I don't know this arc. You don't have to know that arc. You know this triangle, and we just figured out that this is 38 degrees. These 2 are congruent angles, so I can subtract these 2 from 180, and I've found both of these angles. So I'm going to say 180 minus 38 minus 65, and that's going to equal 77 degrees. Our last example, we have a quad inscribed inside of this circle. Remember, inscribed inside, and we're going to solve for x and y. So what I need you to remember here is that opposite angles are supplementary. So opposite angles are supplementary. We're going to label our picture with the given information. So angle A is 4x plus 12. Angle B is 6y plus 10. Angle C is 80, and angle D is 50. And we are to find X and Y. The most common mistake students make is because they're used to parallelograms, squares, rectangles. They try to make these congruent, opposite angles congruent. Look at this. This is an acute angle. This isn't, even though it's not labeled obtuse, to look at it, it looks obtuse. You can clearly see these two angles are not the same measure. We shouldn't always go off of the drawing, obviously, but they're supplementary, guys. They're not congruent, so don't set them equal to each other. So to find X, we're going to say 4x plus 12 plus this 80 is equal to 180 because they're supplementary. Solve this. We would subtract our 92. So give us 88. We're going to divide by 4, and we're going to find that X is 22. Same thing with our Y. So we're going to say 6y plus 10 plus that 50 is equal to 180. So 6y plus 60 equals 180. Subtract your 60. So 6y is 120. Divide by 6. Y is 20. And you've solved for X and Y.